Alright, today we're going to watch a couple videos related to finding the cross sections of three-dimensional figures.
If you were to slice a cereal box with a geometric plane as shown, what shape would result? In this lesson, you will learn how to describe the cross-sections of a right rectangular prism by slicing at different angles. Let's review. In this lesson, we will use a geometric figure called a right rectangular prism. It looks like a box. It's made up of 6 faces that are shaped like rectangles, and they meet at right angles or 90-degree angles. We will also use a plane. Imagine a sheet of paper that is infinitely tall and infinitely wide, but very, very thin, and this could represent a plane. A common mistake: interpreting a perspective drawing as though you were looking at it straight on. For example, here is the right rectangular prism again. Focus on the top face. From this perspective, it looks like a parallelogram, doesn't it? But if we stand it up and look at it straight on, we will see that that top face is actually a rectangle. Some important vocabulary that you will need to know is the word cross-section. A cross-section is the two-dimensional shape that results from cutting a three-dimensional shape with a plane. A familiar example might be a circular glass of water. When it's setting on the table, from this perspective, it appears that the water surface is an oval. But in fact, if we stand up and look at it straight on, we will see that that cross-section is actually a circle. The surface of the water is called the cross-section. Two planes are parallel if they never intersect. We will be using parallel planes in this lesson. Imagine the floor of a room and the ceiling of the same room. These might represent parallel planes. We will also use perpendicular planes. This means two planes that intersect at a right angle or 90-degree angle. Again, think about the floor of a room, but this time imagine one wall of that room. Because they meet at a right angle, the wall and the floor would represent perpendicular planes. Now let's imagine cutting a right rectangular prism with a plane parallel to its base. Here is the prism and a plane that will be parallel to the floor, that is the base of the prism. When we slide the plane through the prism like this, we form a cross-section. Try to imagine what shape that cross-section would have. In this image, you see the cross-section shown in blue. From our perspective, it looks like a parallelogram, doesn't it? But remember, if we stand it up and look at it straight on, we will then see that the cross-section is actually a rectangle. Now let's cut that same right rectangular prism with a plane that is not parallel to its base. When we slide the plane through the prism, try to imagine the cross-section that will result. This image shows that cross-section in blue. Again, it appears to be a parallelogram, but when we stand it up and look at it straight on, we again see a rectangular cross-section. Now let's cut a right rectangular prism with a plane that is perpendicular to its base. Sliding the plane through the prism, we will form a cross-section. Try to imagine the shape of the cross-section. Here it is shown in blue. When we look at it straight on, again we have a rectangle. In this lesson, you have learned how to describe the cross-sections of a right rectangular prism by slicing at different angles. If you were to slice the Great Pyramid of Giza with a geometric plane as shown, what shape would result? In this lesson, you will learn how to describe the cross-sections of a right rectangular pyramid by slicing at different angles. Let's review. One geometric figure that we will use in this lesson is called a right rectangular pyramid. This is a three-dimensional figure formed by taking a rectangle and attaching four triangles called the faces, so that the triangles all meet at a single point called the vertex. The reason we call it a right pyramid is because a line segment that would connect the vertex to the center of the rectangle would be perpendicular to that rectangular base. Another geometric figure that we will use is called a plane. Try to imagine a sheet of paper that is infinitely tall and infinitely wide, but very, very thin. This might represent a plane. A common mistake might be to interpret a perspective drawing as though you were looking at it straight on. For instance, in this rectangular prism, consider the top face. From our perspective, it appears to be a parallelogram. However, if we turn it and look at it straight on, we can see that it is actually a rectangle. Some vocabulary for this lesson is the term cross-section. The cross-section is the two-dimensional shape that results from cutting a three-dimensional shape with a plane. An easy example to visualize would be if you had a glass shaped like a circle and you filled it partway with water. The part of the water that you see appears to be an oval when the glass is sitting on the table. However, if you stand up and look at it straight on, you will see that the cross-section is actually a circle. The part of the water that you see is called the cross-section. Parallel planes will be used in this lesson. These are two planes that never intersect. To help you visualize this, think about the floor of a room and the ceiling of the same room. They never touch. This is representing parallel planes. In contrast, perpendicular planes do intersect. They intersect at a right or 90-degree angle. For example, again think of the floor of a room, but this time think about the wall of the room. They meet at a right angle, therefore these represent perpendicular planes. Now let's consider cutting a right rectangular pyramid with a plane parallel to its base, as shown. If we were to slide the plane across the pyramid, try to imagine what the cross-section would look like. This diagram shows the cross-section in blue. From our perspective, it appears to be a parallelogram, doesn't it? However, if we turn it and look at it straight on, we can see that the cross-section is actually a rectangle. Now think about taking a right rectangular pyramid and cutting it with a plane not parallel to its base. We slide the plane across the pyramid and take a look at the cross-section. Can you imagine what it might look like? Here's a diagram showing the cross-section. If we pull it out and just look at the cross-section, we can see that it has four sides, so it is a quadrilateral. Now let's examine the ends of that quadrilateral. The end nearest to us and the end opposite us are different lengths because on the far end, the triangle is cut closer to the vertex, so it is narrower. Now let's turn this quadrilateral and look at it straight on, and we can see that we have a trapezoid. Next, let's cut a right rectangular pyramid with a plane perpendicular to its base and containing its vertex. Recall that the vertex is the point where the four triangular faces meet. This plane is perpendicular to the base, and when we slide it through the pyramid, we will make sure that it intersects right at the vertex. Imagine the cross-section of this. Now we can see the cross-section. We pull it out, turn it, and look at it straight on, and the cross-section is a triangle. In this lesson, you have learned how to describe the cross-sections of a right rectangular pyramid by slicing at different angles.